Hi guys, Shouvik and welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have the problems, that is number of equivalent domino pairs. Yeah, so on the problem statement they have three consecutive pairs dominoes, but yeah, stay patient guys, we will get different question for sure. But yeah, this question also tagged as an easy difficulty, but I in the side of not to tagged as an easy, but it's kind of a easy medium kind of difficulty. It's not a quite easy, it's a medium side for sure. Yeah, first we will understand the problem statement, then we will jump on the intuitions building and code iterations part, rest of the parts following. Yeah, so given a list of dominoes, so I guess from last couple of days we are also tackling dominoes problem. So domino is, I guess, is clear to us. Domino is nothing but a dice, two dice, n dice basically placed in a two row, first row, second row. N dice placed in a two row is known as a domino. Dominoes I is AB is equivalent to dominoes J CD if and only if either AC and BD, these conditions hold, like both are identical actually. A and C are equivalent, B and D are equivalent, both are identical, like both like top match and bottom match. Or AD and BC are equivalent, that is cross match, that is top bottom match, bottom top match. If any two conditions, like or between them is an or, if any two conditions is hold, then we can say the pair IJ is equivalent. So that is one domino can be rotated to equal to another domino. Yeah, same lines they have written. Now we have to return the number of pairs ij for which 0 ij dominoes and dominoes I is equivalent to dominoes j. Yes, what we expect, that exactly they are looking for. So they basically looking for pairs. They basically looking for pairs which are following these conditions. These conditions, either first one or second one, following any of them. Now on this example test case, you can see this 1 2 and 2 1 are the identical pairs. So that's the reasons they have returned 1. For this example test case, you can see this 1 2, this 1 2 and this 1 2. There are three total dominoes of I, or dominoes of indexes, three indexes which are equivalent. So how many pairs then? 1 2 3 pairs, right? 3 pairs we can build. So that's the reason the output is 3. Yeah, now on the constant part, you can see that constant is very high, like kind of 4 into 10 raised to the power 4. So if you are going to write a n square kind of complexity by running 2 for loop, then you are for sure going to get a time limit exceeded, because your complexity is then going to be 16 into 10 raised to the power 8. So and as we know, anything more than 10 raised to the power 8 is going to be an TL. Yeah, so that's the reason I personally feel it's not an easy. So if they are allow us to submit in big of n square, then it's obviously an easy. But if you have to write something in n or n log n, then it should be tagged as an medium difficulty for sure. That's my personal opinions. But yeah, it's not that much of medium, it's kind of an easy medium problem. Yeah, so now we can go to our intuitions building, where we can start. Yes, okay. Do I connect with my space test? Give me 1 minute guys, let me connect with my space test. It's off. Space test. Okay. Yes, now we can start. Yeah, so I am first writing a domino. So who's are not aware of dominoes, I am giving you a high level understanding what actually is a domino. Yeah, so domino is nothing but there is a two row array you can consider. So this is a 2 row array. There are 2 rows of all the times, and there are A B C D A B B A D C X Y. So that is a domino. So domino, now these values they are giving a range for these values. So the values can be in the range of 1 to 9, and dominoes of ith length is 2. So why the dominoes of ith length is 2? So what they are basically mentioned, dominoes of I, basically if I equals to 0, then they basically giving you this pair they are giving you. So on this test cases, you can see they are giving the pairs. So the pairs of ith index of 0 of dominoes is basically denoting these pairs, right? So now tell me guys, when we are at I, so what actually our brute should be looking like? We will going to run for I in range n, and I'm just giving you the brute, because for brute we can jump on the most optimal solutions, and our j should be start from I plus 1 to n, and on this we can check like if dominoes of I is equivalent to dominoes of j. So that is not a standard equal check. There should be a functions which we can discuss, like what actually it will going to take both the values dominoes of I and j. It is going to give you the results if they are identical. If that is so, then maybe we have an answer variables. We can increase the answer plus answer plus. Yes, and finally we can when we have done our job, we can return our answer. Yes, the brute is bound to looks like something like this. Now how we can check? So check functions is nothing but if dominoes of check functions I am giving you, dominoes of I 0, whatever they have given on the problem statement, right? Dominoes is equal to dominoes of j 0 and sorry, and so this is the conditions with dominoes of j dominoes of I1 is equal to dominoes of j1, whatever the conditions they have given. So that is one conditions. With write the same, like dominoes of I0 is equivalent to dominoes of j, and now this time not 0, cross connections we are going to check, and dominoes of I1, that is of bottom top, another above one is top bottom cross, this one is bottom top, dominoes of j0. If any of them is going to match, then so that is the conditions. Basically you can return any of the conditions is going to be whatever the conditions they have given in the problems. So yeah, brute is very simple. These conditions we are basically checking, right? Yeah, so but that is going to be an TLE. So on the brute, what we can think. So when we have an I and j pointer, so for a particular j, so that is of 2 pointer. Now so we have basically optimally play with what is the first observations coming, optimally play with 2 pointers, or what is the second observation? When we are ith pointer, if we are going to search for all the j, when we are at ith index, and if we are looking for all the j's where j is lying in the range of I plus 1 to n minus 1, if we are going to look for all the j, then that is not going to give you a optimal solutions. Now every 2 pointers are associated with back computation, rather than from I. If we are going to look for the j, what is we are generally doing in the 2 pointers? So that's the reason I am definitely going to suggest you guys, please go to our sliding window 2 pointer playlist. You will get the j's, like the intuitions building you can feel on your own. Now rather than from I to j, because from I, if you are going to compute all the j's, you have to run a for loop from I plus 1 to n minus 1 to find all the such j's. But rather than if we are at jth index, if we are at jth index, and if we are going to look for reverse, what all the i's for whatever the range j minus 1 to 0, what all the i's, we have an I set here, what all the i's in the range of 0 to j minus 1, satisfying the conditions, right? So like this way, j is only going to run in forward, and we should store our I values to some what can I say, like frequency list, frequency map kind of data structure, so that we can call that dictionary, or frequency map, which is going to tell me the count, how many i's in the range, what we are looking for, how many i's satisfying this condition, the conditions, right? That exactly we are looking for, right? So that actually a kind of like more general intuitions we can set. So now if I can go to jump on the pseudocode, but before jumping on the pseudocode, then there is a question, right? We are going to encounter 1 2 previously, and we are going to encounter 2 1 later. So for 2 1, if our dictionary, let's suppose the frequency data structure that we are talking about is going to store 1 2 as a key, then for 2 1, it is not going to get a hit, no hit for 2 1, right? And we are going to miss that pairs. So when we are pushing the values to the dictionary, we will make our key static. So what's the rules of the key? The rules of the key should be it follows. So key should be of two pairs of integers, x and y, x and y. So this pair should be x less than y, less than equals to y for all the cases, should be all the cases, then it is going to be unique. So for 2 1, we are not going to get direct check to 2 1, we are going to make our key by the formula 1 2, like smaller one first, bigger ones later. You can make your key like x greater than equals to y, that is also fine, but be stick with one, either your key should be small big or your key should be big small, anyone fine, and that's the way you have to check when you are searching for. So for 2 1, you are not going to query your dictionary. If you are following small big key pattern, then you are not going to query your dictionary with big small. You are first build your key with the rules that you have defined very starting, then you have built your key like 1 2, then it is going to get a hit, for sure. It is a hit, and you are going to get the count. Yes, like this way, when we are iterating on the jth index, if our dictionary is going to tell me how many pairs we have already encountered which can make pair. So when we are at jth index, so how many eyes to which my j can pair, right? So that is going to tell us by our default dict or the frequency map on other language if you are following. If that is so, then I think our problem is solved. We will just run a forward for loop and we will check if how many keys before its count increase, how many keys we have found. So that's the number. So whichever the dictionary is going to return us, we will giving the return, we will increase our answer that many times, and we are going to add. So don't forget to add your key also to the dictionary, to the patterns that we are following, right? Yeah, so now we can quickly discuss the pseudocode for same. So I think now it is going to be very simple. So I am writing for x comma y in Domino's. So Domino's should be a couple of values, x and y, that is top and bottom. And what we are going to check, we are first build your key. I am following small big patterns, you can follow big small pattern, that is also fine. So mean of x comma y is our mini, and maxi should be what? Max of x comma y, that is going to be our maxi. So our key is mini comma maxi. And what we are going to increase to our answer plus equals to our default dict of whom our key is mini comma, tell me guys, mini comma maxi, right? Mini comma maxi. So whatever the count we already have it in our dictionary, we are increasing our answer. And finally, for this particular value that we have encountered, we are increasing our mini comma maxi to be plus equals to 1. And finally, whatever the answer we have stored, we are returning our answer. That's it. The problem is as simple as that. You will definitely get an AC for this. Yes, so now we can go to the code iterations, but I have written, I think it's almost the same code here. Yeah, so here you can see I have initialized my default dict. Answer is this, default dict of int. Answer is going to be initialized with 0. X comma y in Domino's. My key is mini is min of x comma y, maxi is max of x comma y. Answer plus equals to dd of mini comma maxi. So that is our key. And dd of mini comma maxi plus equals to 1. We have increased your discount, and finally we have returned the answer. Yes guys, the problem is as simple as that, but yeah, like you have to build your intuitions in the step-by-step way, then only you can come with the most optimal solution. So that's the reasons I am initially stating it's kind of an easy medium. It's not a like easy tech, it should be tagged as a medium. So because based on the constant, if we can use n square time of complexity, then it should be like an easy tech problem. So on time complexity, we are running a single for loop for sure, and inside that, do we do anything? No, all are like a value fetch from dictionary and increase to dictionary, which we all know is a kind of for sure a big of one kind of time complexity. So the time complexity for this problem is for sure of big of n. And on space complexity, on space, tell me guys, what actually the space, how many keys we can put on the dictionary, so that basically depends on how many numbers, how many distinct numbers you can build, So our key is nothing but 2 numbers from 1 to 9 numbers. Now if I can again go to our 1, no? So you have numbers from 1 to 9, and from them you have to choose 2 numbers to build your keys. So what is the formula guys? If you done your mathematics on 11 and 12 standard is very good, like your permutation combination is very strong, then you should be tell me. So out of 9 we have to choose 2. 9c2. Yes, that many keys you should have to find. So how many it is? 9c2 is nothing but 9 factorial divided by 2 factorial into 7 factorial. So if I can write it like, if I can go to our next line, it is going to be 9 into 8 into 7 factorial. 2 factorial is nothing but 2 into 1 and the 7 factorial, now I can cancel both. 2 factorial is going to cancel with this, so 9 into 4 is nothing but 36. So there should be 36 different keys we are going to push to our dictionary. But don't tell 36 in interview. Don't tell 36 in interview. Your your space complexity, and remember, right, 9C2 consider 12 as an element and 22 also as an element. But for our case, 1 2 is a valid and 2 1 is also valid. Like this way we have 36. But for our case, how many we are pushing? For them, we are pushing only single one, that is of 1 2. So it is not exactly 36. It's obviously bound by 2 with 36, because for 9C2 it is also considering 12 and 21 both in 36 computation. But for our case, it is of 12 only, not 21 we are going to consider. So 36 by 2, what is the only forward pairs, not the reverse pairs, so 36 by 2. So our dictionary can grow as big as 18. Yes, so our space complexity, so it's nothing but big of 18, which is kind of like big of 1 only, because it is a constant space. Yes guys, so that obviously the time and space complexity that we can most optimal, I definitely have to say that is the most optimal solutions that you can achieve for this particular problems. And why I am explicitly mentioning this space complexity with one node explanations, with one node like these formulas deriving. So basically there is an mathematics associated with the space, because you have created dictionary and you have like pushing the keys in the order of small big or big small. So there are how many ways? 9C2, and out of them like 1 2 and 2 1 both are considered, but we are sure, so we are either pushing small big or big small, so it is nothing but 36 by 2. So please explicitly mention such factors to your interview. That is actually creating an impact, like making yourself a different from the other candidates, because other candidates mostly going to say like big of 9 kind of complexity, or like big of how many distinct elements, or if they are super good, then maybe they are going to say like 36 9C2. But you have to prove yourself you are like more than super good. So that's the reasons you have build your formula 9C2, that is of 36, and post that also you never miss that computations. We are only pushing the forward small big or big small, so that is nothing but 36 by 2 also. So that is exactly the space of all the test cases you can given me. That is the space we are only going to consume at worst case. So please explicitly mention in such a note. So there is no chance to you are going to be rejected on an interview. So yes guys, so that's it for this particular problems. And if you guys are able to understand till this point, so I guess you guys are already doing, so please do subscribe to our channel. Please share the videos to your friends who are also preparing for top product based company and brushing up their TSL skills. And please turn on the notifications so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.